Let's jump right into this explainer because we really need to completely reframe how we think about water damage. I mean, most people picture a flooded basement or a burst pipe and think, well, it's just a heavy duty cleanup job, right? You grab a bunch of towels, maybe rent a wet vac from the hardware store, point a box fan at the floor, and just kind of hope for the best. But the reality, especially in highly specific geographic areas, it's not a cleanup. It is absolutely a rigorous, highly calculated, scientific rescue mission. Today, we're dissecting the exact anatomy of a water disaster. We're going to use Varina, Virginia as our prime example to analyze the heavy-hitting science that professionals, like the crews at Horizon Water Damage Restoration, deployed to literally save a structure before it's too late. And our starting point has to be the ground itself. We have to look at how specific local geography basically cooks up the absolute perfect storm for property damage. So Varina sits right in a flood-prone corridor. But it's not just the seasonal flooding from the James River that's the issue, it's the actual dirt. The whole area is packed with this heavy, dense clay soil that flat out refuses to absorb heavy rainfall. Now, add to that a climate where the humidity just hangs out above 70% for a huge chunk of the year, and then throw in aging infrastructure. Think about neighborhoods like Highland Springs, where you've got homes still relying on 1960s plumbing and old cast iron pipes. Put all that together, and you don't just have a water problem. You have an environmental pressure cooker that is just waiting to pop. So to understand exactly how the pros tackle a beast like this, we split things up into 5 key areas today. First, Varina's perfect water storm. Then, the ticking mold clock. Next, emergency extraction protocols. After that, the actual science of structural drying. And finally, rebuilding and navigating those tricky insurance claims. We are going step by step through the entire life cycle of a water disaster to see exactly how professionals fight back. All right, part 1. Varina's perfect water storm. So the really crucial thing to grasp here is that Varina's dense earth does not absorb water at all. When a heavy rainstorm hits, all that water has to go somewhere, right? Because the clay acts almost like a freshly paved road, the runoff is forced straight toward the path of least resistance. And unfortunately, that usually means house foundations, crawl spaces, and basements. It is basically a natural funnel, just directing groundwater right into the vulnerable lower levels of older homes that were built way before modern waterproofing standards even existed. Now, what's really fascinating is how the nature of this disaster completely shifts with the seasons. In the winter, when temperatures suddenly nosedive below 20 degrees, the threat comes from the inside out. You've got these aging, corroded supply lines that freeze, eventually burst, and boom, suddenly you have hundreds of gallons of water exploding directly into finished living areas. But in the spring, the threat totally reverses. It comes from the outside in. Relentless outdoor groundwater pressure, saturated clay soils, and spring thaws literally push water up through foundation vents and cracked concrete walls. So you're dealing with entirely different seasons, which requires entirely different science to fix. Moving into part 2, the ticking mold clock. Okay, so you have a disaster, you have standing water in your home. But the real terrifying question every property owner needs to ask is this: how fast does a wet floor transition from being just a structural headache into a severe toxic health hazard? Like, how much time do you actually have? The answer is pretty shocking: 48 hours. That's it. Because of Varina's notoriously high baseline humidity, staying above 70% for so much of the year, mold spores, which are naturally floating around everywhere anyway, find their absolute perfect breeding ground. If porous materials, drywall, carpet, subflooring, if they get wet and stay wet, mold begins colonizing within an incredibly tight 24 to 48-hour window. This isn't some hypothetical thing that happens weeks down the line. It is literally happening by day 2. And this timeline is exactly why a 60-minute emergency dispatch is absolutely vital. Every single minute that water sits there, it's wicking deeper and deeper into your drywall and your framing. Look at hour 1. The goal is purely stopping the bleeding with rapid water extraction. By hour 24, you have to be in the critical drying phase to halt secondary damage, stuff like wood swelling and rot. Because if you hit hour 48 and that moisture is still trapped inside, you are no longer just dealing with water damage. You're now facing a full-scale mold remediation project, complete with HEPA filtration and negative air pressure barriers. It becomes a whole different ballgame. Which brings us to part 3, emergency extraction protocols. So, the global industry standard, which is known as the IICRC, has very strict categorizations for water. Professionals do not treat all floods equally. The source of the water completely dictates the protective gear and the extraction methods they have to use. Category 1, that's your clean water. Think a fresh supply line break.
It's totally safe as long as you dry it incredibly fast. Then there's category 2, gray water. Maybe a washing machine overflows and brings some chemical contaminants with it. That's going to require surface disinfection. But category 3? Yeah, that's black water. Think raw sewage backups from older collapsed drain lines. This stuff demands full hazmat-style personal protective equipment, heavy antimicrobial treatments, and the immediate total disposal of any porous materials that just cannot be safely sanitized.
And the extraction phase isn't just about what you can see pooling on the floor. The pros don't just look for standing water to tell them where the damage actually is. They bring out thermal imaging technology to locate hidden moisture pockets. Wind-driven rain or even a super subtle pipe leak will run down wall cavities way, way far from the source. Without those thermal cameras tracking that invisible wicking effect behind your drywall, you might dry the surface completely, but leave the structural framing soaking wet inside the wall, which is basically a guarantee for future rot.
Let's get into part 4, the science of structural drying.
So, structural drying relies heavily on a field of physics known as psychrometry. Honestly, the technicians aren't just guessing how many fans to plug in. They are doing hard calculations. They assess the thermodynamic properties of the moist air to figure out the exact dehumidification capacity required based on the room's total volume, its temperature, and its relative humidity. It's a literal mathematical formula used to manipulate the environment and force water to evaporate. Which brings us to this really cool concept called vapor pressure differential. By pairing industrial air movers with commercial dehumidifiers, professionals create incredibly specific airflow patterns. They're actually manipulating the room's atmosphere to create a pressure difference that literally sucks the trapped water right out of the solid wood structure, pushing it into the air. And once that moisture is airborne, those heavy-duty dehumidifiers capture it and pump it straight out of the house. And honestly, this exact science right here is why DIY cleanup almost always fails. If you just rent a standard carpet fan, you are only drying the surface layer. Without the precise science of laminar flow, which means moving air in parallel layers across the wet surfaces, and without those psychrometric calculations we talked about, the structural core of your home remains dangerously wet. You might walk away thinking the job is done, but the framing hiding inside your walls is just slowly rotting away.
So, how do they actually know when they're finished? Well, the drying phase does not end until penetrating moisture meters prove that the wood framing has reached a safe moisture content strictly below 15%. And get this, for concrete slabs sitting under hardwood, it has to be below 3%. That requires twice daily monitoring and logging to make absolutely sure the data matches safety standards before a single piece of new drywall ever goes back up. Finally, part 5, rebuilding and navigating claims.
The entire mitigation event follows this 3-phase master process. Step 1, you stop the damage. Step 2, you remove the moisture and neutralize the mold threat. But step 3, that is all about continuity. Having the exact same crew that extracted the water also install the new insulation, hang the new drywall, and finish the paint and trim, that ensures absolutely nothing gets lost in translation between random subcontractors. It takes the property out of pure crisis mode and seamlessly brings it all the way back to its pre-loss condition.
But remember all that rigorous scientific monitoring we talked about, the thermal imaging, the daily moisture logs, the psychrometric calculations? Well, it serves a second, incredibly vital purpose. It provides the exact, undeniable data that insurance adjusters demand before they approve your claim. Look, if you just tell an adjuster your floor was wet, they might push back. But if you hand them daily moisture mapping, penetrating meter logs, extensive photographic evidence, and rock-solid proof of industry-certified methodology, that totally streamlines the whole process and prevents those annoying claim delays that could otherwise leave you covering thousands of dollars out of pocket. To sum it all up, surviving a water disaster isn't about hoping your house just kind of dries out in the summer breeze. It's about deploying precise science, calculated air pressure, and rapid response to save the structure from catastrophic secondary damage. From minute one, it is a calculated, scientific rescue mission. Which leaves us with a pretty critical thought to consider about your own property's hidden vulnerabilities. I mean, we know what happens in a massive flood, but what about the slow drip? Based on everything we've just uncovered about how wildly fast mold colonizes and how deeply water wicks into framing, what hidden moisture do you think is trapped behind your walls right now? Keep an eye on your foundation, watch out for those small leaks, and definitely remember the science next time you spot a drop of water where it just shouldn't be.